If you want to get to the opposite end of the world, it's a hike, about 20,000 kilometers. But what if you didn't have to travel across the surface? What if you could dig straight through to the other side? If you're trying to dig to China from the US, there's something you should know first. The opposite point on the planet isn't in China. It's somewhere in the middle of the Indian Ocean. So, to get to China, you should start digging in either Argentina or Chile. Your first challenge would be digging through the Earth's crust. It's the thinnest of Earth's 3 main layers, yet humans have never drilled all the way through it. As you descend, you'd soon reach the depth of the Paris catacombs, the deepest metro station, and the devil worm, the deepest animal we've ever discovered underground. Then it would start to get hot. At 4,000 meters down, you'd pass the deepest mine on the planet, which is cooled with ice to make workers comfortable. Because down here, temperatures are 60 degrees Celsius. By 8,800 meters, you'll be as deep as Mount Everest is tall, but it's still not the deepest point humans have ever dug. That point is at the bottom of the KHOA super deep borehole, at 12,260 meters below the surface. Down here, there's 4,000 times more pressure than at sea level, and temperatures push 180 degrees Celsius. So you'd need a lot of insulation to carry on and keep from melting. At around 40,000 meters, you'd reach Earth's second and largest layer, the mantle, which makes up a whopping 84% of the planet's volume. Near the border, temperatures climb to around 1,000 degrees Celsius, hot enough to melt many metals, like silver, but not a steel drill. And good thing, because you'll need it to drill through the first part of the mantle, which is made of solid rock. Until you reach 100,000 meters, that is, when you might need to switch to a propeller. Here, the pressure and temperature are so high that in some places, rock takes on a caramel-like consistency. In fact, it's this rock that ultimately erupts from volcanoes on the surface. At 150,000 meters, keep your eyes peeled for diamonds. They form when heat and pressure restructure the carbon atoms in this region. Once you reach 410,000 meters, the rock is solid again, so it's back to the drill. You see, while it's still plenty hot at this depth to melt rock, the pressure is so extreme that the molecules inside literally can't move into a liquid state. Then by 3 million meters down, you'd reach Earth's third layer, the outer core. Unlike Earth's crust and mantle, the core is made of iron and nickel. Temperatures here are the same as the surface of the sun, hot enough to melt all that metal. So, yep, back to the propeller. And it would have to be made out of some kind of super material, because no known element has a melting point above 6,000 degrees Celsius. Making matters worse, the outer core also has low gravity, because when you're that deep, much of the planet's mass is now above you, which produces a gravitational force that pulls away from the center. So, to continue, you'd need a superheat and pressure-proof submarine that moves like rockets in space by shooting fuel out the back end. You'd soon arrive at the inner core, around 5 million meters below the surface. The inner core is one giant sphere of solid iron, so it would definitely be challenging to get through. But if you did find a way, you'd soon hit the halfway point, about 6.4 million meters down, also known as the center of the Earth. Now, there's nearly the same amount of mass all around you, pulling you equally in all directions. So there's zero gravity here. And now is when the trip really gets hard. The second half. Because as you dig past the inner core, you'd soon feel the pull of gravity again. And this time, it'd be pulling you from above, where the majority of Earth's mass is now. So, while you might be digging down relative to where you started, it'll feel like you're climbing up. And if you didn't have those handy rockets propelling you, you'd fall right back to the core. But 6.4 million meters later, after powering through impenetrable iron, molten alloy, and solid and mushy rock, you'd arrive, at long last, on the other side, in China. That would certainly come as a relief, but it wouldn't even be the best part. Assuming you left a tunnel through the center of the Earth behind you, you'd now be able to travel back and forth between China and Argentina in under an hour, simply by jumping in. To learn why, check out another video we made about jumping through the center of the Earth.